Yeah, so homework question 5.20. We got a sample of sand that's at 21.5 degrees Celsius, right? And in this case, we add heat. Oh, okay, thank you. Yeah, so temperature for the previous one, they wanted 2 sig figs only. Yeah. We absorb 1,300 joules of energy. And the sand goes from 21 to 67 degrees Celsius. They want to know the mass, given that the specific heat, right, of the sand is 0.84 joules grams degrees Celsius. All right, what happened? The Bills don't have the ball anymore. Please don't tell me they had a turnover. All right, so Q equals MC delta T. I put in 1,300 joules of energy. I don't know. Oh, okay. Man, I don't know the mass. That's what we're looking for. 0.84 joules grams degrees Celsius. And then my delta T, right? Final minus initial. So 67 minus 21.5. Right, 45.5. So we're going to solve for mass, right? So mass equals 1,300 joules divided by 0.84 joules grams degrees Celsius, 45.5 degrees Celsius. Right, the mass of the unknown sand, 1,300 divided by 0.84 times 45.5. I get a mass of about 34 grams of sand. Here for significant figures, I would go 2 again. I guess I was wrong on the first one, but I would go 2 as well here, and just say 34 grams of sand for question 20. And then for Yuna's question about do I always flip the sign, it depends. This is like question 19 was one of the rare questions where they said heat liberated implies that it's a negative number, put a positive number. But typically, if it's heat released, it's going to be a negative number. If it's heat absorbed, it's going to be a positive number. Yeah. So like MK said. All right, question 20. We did 20, 21. Yeah. So are we all set then with yeah, it's C of S. It's our C of S. That's our specific heat, right? Our specific heat of the sand. So it's a little S there, yeah. No, I'm just saying, do we need to do 21? Because 21, 19, 20, and 21 are all kind of the same, just using the same equation, just different variations of that. So if we want to work through it, we can. All right. Yeah. 11 ounces of water is heated. 11 joules of heat, 1,100 joules of heat. Yeah, 42 is on the list. The final temperature, right? So yeah, 42 is on the list. Yep, 44 is also on the list. 11 ounces, 2 milliliters. So 11 ounces is 325.3 milliliters. All right, back to question 21. All right, so we heat 325 milliliters of water. we know the specific heat, right? The heat capacity, the specific heat of water is 4.184 joules grams degrees Celsius. And we want to find our final temperature. Yeah, we're going to start with the homework questions, and then we'll do the practice exam questions in the second half. And then, yeah, one gram, like we're always going to assume for water that density is 1 gram per milliliter. All right, so question 21, I've got 1100 joules, right? I add 1100 joules of heat. The mass of water is 325 grams. The specific heat, 4.184 joules grams degrees Celsius. Delta T is what we're looking for. So we divide that across, right? 1100 divided by 325.309 times 4.184. And yeah, I get a really small delta T of 0.808, right, degrees Celsius. That's my change, my initial yeah, we're working on question 21. Right, my initial temperature is 19.1 degrees Celsius, 19.5 degrees Celsius. We're going to go up 0.8 degrees more, right? So we're just going to have 20.3 degrees Celsius be our final temperature. So everyone can see the questions. Just post direct message, just post public messages that everyone can see. So I'm not answering private messages that only one person sees, right? This number, the 1100 joules, right? This is a variable. It's going to be different for everyone, right? So yours might be 1189, right? I just had 1100, right? So the steps would still be the same, even though the energy, your initial energy might be a little bit different. So I had that initial energy. I had 11 ounces of water, which I just converted to milliliters. So yeah, it just depends on your question, right? Those numbers might be variables. All right, now we're going to go over to 34, 35, 36.